Okay, so where we left off in the last video is we created a random chair spawning algorithm, and we saw right off the bat that this algorithm had some shortcomings. And the biggest problem is that there's the possibility for chairs to be overlapping one another. There's not a huge chance of it happening as long as the area is big, but it's still a possibility. Here we see the chairs, these two chairs here are overlapping one another. And yeah, it looks like over here, these two chairs are also overlapping one another. So we would like to be able to spawn a bunch of random objects in this room or on this floor without having to worry about objects overlapping one another. So we're going to get into how to do that in this video. So what I'd like to do is I'd like to go back into Visual Studio, and we've made this spawn item function where we basically just spawn an item at a random location given some constraints, and we pass in the U class, in this case the chair class. I'm going to go ahead and delete these function calls to that. And what I'd like to do is, since we have this nice grid material, we can kind of use this as a sort of baseline. What I'd like to do is create a grid of, say, 200 by 200 squares, and give myself a grid in which to spawn objects. So that way each object has its own little square designated to it, and we can spawn the object at a random location in that square. And so to get an idea where these squares are exactly, we can draw some debug lines. So I'm going to go ahead and do that. Let's go ahead and open up Visual Studio, and let's create a function here that will help us to visualize things. So I'm going to create a function to help create a grid or draw a grid. So I'm going to make a void function and call this create grid. It's not going to take any parameters. So we have this create grid. I'm going to define it here in procedural room.cpp, and got to fully qualify the name, give it a function body. And what I'm going to do is I'm going to loop. So I'm going to say for, I'm going to use int32s. I'm going to call this I, set it equal to 0, and say I is less than, and how many grid spaces are there? Well, if we look, we'll see that we have, this is 1,000 by 1,000, and if these are 200 by 200, then there's 5 grid squares, 200 by 200 squares, across the length or the width of this. And so if I want to avoid hard copying, or hard coding rather, then I can create a couple of float variables here. So I can say float, and we can say square width. I can also say float grid size and x. Actually make this an int32 grid size x and an int32 grid size y. So the square width is 200, and the grid size x and y are both 5 because there are 5 grid squares across the length and the width. So in the constructor, I can simply set these. I can say grid size x equals 5, grid size y equals 5, and square width equals 200 dot f. And so we have these as values that we can change. So I'm looping from 0, and I'm going to say I is less than grid size x and I++. And so what can I do here? I can draw a debug line from a start location to an end location. So my start location, it's going to be a vector. I'm going to call it start, and I'm going to set it equal to, and I'm going to say I'd like to know exactly where my dimensions are for this room. So I'm going to go ahead and I'm going to take this room. You'll see that the center of the room is at the origin, but I'd like the center of the room, or I'd like the origin to be at sort of this top left corner here, because you'll see if you look in the world in the world dimensions, the x direction goes to the right, the y direction goes down, and I'd like the origin to be the top left corner of this. And to do that, I can set its location in the x to be 500, and its location in the y to be 500. And now you'll see that the top upper left corner of the room is at oops, I moved it, is at the origin of the world, or 0, 0, 0. And I'm also going to take this player start and I'm going to move it over here so that it's actually facing, I'm going to rotate it by 90 degrees so that it's actually facing the correct direction, so we can sort of visualize this a little bit better. So I'm going to bring it upwards, up in the air. I'm going to have it tilted down a little bit, and that way we can see what's going on. And of course, the chairs are they're spawning with the, basically with the same algorithm that used the floor being having its center at the origin, but we'll fix that. Okay, so we got this floor, and we know the top left corner is at 0, 0, 0, and because it's 1,000 by 1,000, then the bottom right corner is 1,000 in the x and 1,000 in the y. And so what we can do, we can store the location of the upper left or top left and the bottom right of the room. So I'm going to go ahead and store those as well. They're f vectors. I'm going to say top left, and it's going to be 0, or actually we'll initialize these in the constructor. So top left and bottom right. And so in the constructor, we'll go up here and say top left equals f vector 0.f, and that'll just give it all zeros. And then bottom right is f vector, and it's 1,000 by 1,000 and 0 in the z direction. So down here in our for loop, we're going to say start. Where are we going to start our grid? It's going to be basically the top left, but since we're looping through this, I'm going to say that start is equal to top left plus f vector with a value of I times square width with 0 in the y. And let's go ahead and put this at, rather than 0 in the z, I'd like to raise it up by about a unit or so that way the lines will be more clear. And so I'm going to say grid height. I'm going to create a float called grid height. And I'm just going to set that equal to 1.f in the constructor. And that way we can use grid height here. So the start will be at the top left, and as I increases, when I is 0, then this portion will be 0, so it'll be 0, 0 grid height. However, when I becomes 1, then this will be 1 times square width, which will be 200, and so we're jumping ahead by 200, increments of 200 each time in this for loop. So that's where the start of the line trace will be. The end of it will be, however, f vector end. It'll basically be the start plus f vector, and we're going to do a 0.f in the x direction, and then the room length, which should be 1,000 in the y direction, and we'll do grid height for the z. So we have room length here, and I think I called it maybe, let's see, did I call it something else? Actually, I don't think I have the room length here either, so I'm going to go ahead and make a float called room length and a float called room width. And I'm going to initialize these to 1,000 up here. So room length equals 1,000, and room width also equals 1,000. And then down here, room length, this will be 1,000. So we're starting at the top left, right? We're starting at the top left, and we're ending at the top left plus this vector, which is basically pointing across the y direction all the way across the room. And so what we can do is we can draw a debug line. And so to draw a debug line, we're going to include an include here it's called draw debug helpers dot h, and now we have access to functions like draw debug line. And so we're going to use draw debug line. So draw debug line, and the first parameter is the world, so we need to use get world. The second is the line start. The third is the line end, which will be start and end. Then there's an F color, and I'm going to choose white, or I'm going to choose blue actually. And then for persistent lines, I'm going to say true, and we don't need any of the other arguments. So this will draw a bunch of lines from the top left all the way across in the x direction, and they're ending at their start location plus this vector, which reaches across in the y direction. So you'll see here, if we hit play, actually it's not going to draw because we're not calling create grid. I want to call create grid and begin play. And so since we're drawing this, we should see a bunch of lines, and here they are. And so you'll see that we've got a line starting on the very left all the way over, and we don't have one at the very end. So instead of looping through to grid size, I'm going to say grid size +1. And that will make sure that we have a line all the way at the end as well. So I'm going to do another for loop to do some horizontal lines. And so we can copy this. It doesn't matter if we use the I again. We could change this to a J if we wanted to, but it's not that important. So the start is going to be the top left, only instead this time the x component of this vector that we're adding is going to be 0, and the y component is going to be I times square width. And then the end is going to be the start plus, and instead here the x will be the room width. The room width, which is the same as the room length. They're both 500, or they're both 1,000. And then the y component will be 0, and then we have our grid height. And then of course we'll draw the debug line just like we did here. So this way we should have a nice grid, and there's our grid. So I wanted this so that we could visualize our little designated areas that we would like to spawn items in. And so how are we going to spawn items randomly inside of the grid? Well, there's a couple of things that we need to take into account, and we'll get there. But for one, I'd like to create a function that can get us a random point in a square, taking its upper left and lower right corners. So let's create a function down here. Let's say it's going to return an f vector, and I'm going to call this get random point in square. And it's going to take two vectors, an upper left and a lower right. I'm going to make these const f vector references, so that way they get passed in directly without being made copies, but we can't change them once we once we pass them in. We'll call this upper left and const f vector reference lower right. So this will get us a random point in the square. Let's go ahead and define this. Give it a fully qualified name here. And how are we going to do this? Well, let's create a float, and I'm going to call this random x, and it's going to be fmath fRandRange, right? This gives us a random number. And for the minimum, we're going to say upper left dot x, and for the maximum, we're going to say lower right dot x. You see, if we have the upper left corner and the lower right corner of a square, then we know its dimensions. We know the location of its x of the left side of it, as well as the x of the right side, because that would be the upper left x component and the lower right x component. And similarly, we can get the y components as well. So let's make a float called random y and set it equal to fmath, f rand range. And we're going to say upper left dot y and lower right dot y as well. And then we can simply return an f vector, and the f vector will be have an x of the random x, that will be its component for the x, and then its y will be random y, and then we can just simply set the z to grid height, because we're just assuming everything that we're going to spawn should be at the grid height. And if we wanted to, we could actually set this to 0, and then once we do anything with it, we could, if we spawn something or if we do like a debug point or something, then we can set that grid height there. So let's make it 0. So there's our get random point in square function, and now I'd like to place some points on the grid. So let's make another function for doing that. Let's make a void function, and let's call it place points on grid, and it's also going to take 0 parameters. And we're going to go ahead and define this in here. And so how are we going to define this? Well, I'd like to do a nested loop from across the x and across the y. So I'm going to say I'm going to say int 32 I is equal to 0, I is less than grid size x. Remember, grid size x is an integer, and we set it to 5, so we're looping from 0 to 4 basically. And then we're going to do I++. Now inside of this, we're going to do another for loop, and I'm going to say int 32j, and it's going to go from 0 to grid size y. And then this will be j++. And then inside here, we can do something for each I and j going from 0, 0 all the way to 4, 4, which corresponds to the grid squares. So what I want to do is create an upper left and lower right for the current square we're working in. So I'm going to say f vector. I'm going to call this upper left, and I'm going to set its x component equal to I times square width, and I'm going to set its y equal to j times square width, and I'm going to set its z to grid height. And I'm also going to create a lower right. So f vector lower right. And this is going to be I times square width. And I'm going to add on another square width. So this is the same as the x component of the upper left, only we're adding another square width to its x component. So it's basically, if I go back into Unreal Engine and press play, the upper left of any given square is right here, and the lower right for the x will be this same x value plus 1 square width. So that's why I'm adding another square width right here. It's going to be I times square width. At 0, it's going to be just 0. And at 1, it's going to be 200, and so on. And we're adding another square width on top of that. The next is going to be, the y is going to be j times square width. And the z is going to be grid height. And so we can get a random point in the square, f vector, and let's call it random point in square. And we can say get random point in square, And remember, that's the function we made here. It takes an upper left and a lower right. So we can pass in upper left, lower right, like that. And now we have, for each square, we have a random point inside of that square. Now we're going to see exactly why this is not quite right, not quite ready as far as the algorithm goes. It's not quite perfect yet, but we'll figure out how to get it that way. And we're going to see why it's not perfect. So what we're going to do is we're going to draw a debug point. So we're going to say draw debug point. And we're going to first pass in get world. It needs the world. And we're going to say for the point location, random point in square. That's the random point we just got. For the size, we'll just give it a size of 5.f. And for the color, let's make it red. And we'll say true for draw persistent lines, and we'll compile this. So all we're doing is we're looping through each point on the grid. We're getting the upper left corner, the lower right corner, and then we're using our random point in square algorithm to get a random point inside of it. And now we can draw those points. Oh, and we're not going to get the points if we don't call the function. So we're going to call place points on grid, and we're going to call that in begin play as well. So now that we're calling this, now we should see some points on the grid. And so now we'll see that each grid here has points, and it actually looks like these points are on the grid itself and they're not inside. They're not inside of the square. So let's see why. Let's find out why. And grid height, we're getting a lower right with I times square width plus square width. Oh, and yes, J should also have an extra plus square width as well for the lower right. And so in that way, we actually have the lower right and not what was actually the upper left Y component. So we'll fix that little typo, and we'll come back. And now you'll see we actually get random points in these squares. And so this is great. So we now have random points, right? And these can be points where you can spawn, they can be locations where you can spawn objects. But let's visit one reason why this algorithm isn't quite ready yet. And we can do that by not only drawing debug points, but also let's draw some debug circles, and this will help us explain why this algorithm isn't quite ready yet. So let's draw debug circle, and the first argument is the world. So the center of the circle can be random point in square. The radius, we're going to give it a radius of 25.f. Segments, we'll give it 48 segments so it's nice and round. Color, F color, let's make it red. Persistent lines, I'm going to say true. Lifetime, I'm going to say -1.f, so it's persistent. Depth priority will be 0. We don't need to get into that for this video. The thickness, that can be, we can say 2.5f. Draw axis, we'll go ahead and say false, and it's going to allow me to use a 0 or a z-axis, and let's see here. Let's see if I can. Yeah, I can do a y-axis and a z-axis. I'm going to go ahead and give it a y-axis of an f vector of 0.f, 1.f, 0.f. Then for a z-axis, I'm going to give it an f vector, 1.f, 0.f, 0.f. And then finally, to draw axis, I'm going to say true. Okay, so that's a lot of parameters there. So this should draw a debug circle. So let's go back and take a look And we'll see right off the bat here is the problem with our algorithm. Some of these circles are overlapping. So my point was, the reason I drew a circle was because any object with at least a radius of 25, and I know not all objects are circular, but if the object can have a random yaw rotation like a chair, if you rotate that chair around, the outer corners of that chair will trace around a circle. And so a circle can give you the outer bounds of how far that item can reach. And if we were to drag a chair in, and we were to take this chair actor and place its location at, say, the origin, we can come over here to the origin. We can look down at it, and you can see that it's got its own radius here, and it's probably something around possibly the diameter of this circle. So it's got probably a radius of about 50, because the circles have a radius of 25. And so, you know, the radius of this chair, it looks like if you were to draw a circle around the chair from the center to the outermost corner, it looks like it's about this length, the diameter of this circle. And if the circle's radius, which is half of its diameter, is 25, then its whole diameter is 50. So I would say this chair has a radius, if you were to trace it into a circle, of 50. So how do we make sure that we don't overlap? And the answer is actually quite simple. We simply need a radius for the object that we're spawning, or for the circle we're drawing in this case. And for that radius, we need to accommodate for that when choosing our random location. So let's go back, let's create a float called radius, and let's give it a value, and let's give it just a value of 25, since that's what we've been working with. And so down here, while we're drawing the debug circle, 25 here, this is radius. And we'll use the radius here when choosing our upper left and lower right bounds for our random point in the square. And basically all we're going to do is we're going to take our upper left, our x, and we're going to add radius to it. Why are we adding? Because if we go back in here and we hit play, you'll see that the upper left here is the positive x direction, and downward is the positive y direction. So we need to go forward in 25 units and down 25 units to make sure that this circle does not actually go past outside the perimeter of the edge. So we're going to say we're going to add radius to the x, we're going to add radius to the y, and for the lower right needs to be subtracted by 25 in the x and subtracted by 25 in the y, so that way our bounds will prevent the circle from going past the grid. So here for lower right, we're going to subtract radius, and for the y, we're going to subtract radius. And just like that, we are enforcing that our circles do not get too close to the grid lines, and therefore they will never ever cross each other. There will never be two circles that will overlap with each other. And so that's actually pretty cool. Now what we can do now with this is we can spawn some chairs. Now I'm going to open up the chair. Now we know that the radius, if we look down from above, from the center to the outermost corner, is about 50. So if we take the chair component and we scale it down, so we take the chair, we take our scale, and we scale it by half. Now we have a chair whose x, y, and z scale components are all half what they were. Oops, I lost my chair. There it is. They're half what they were, so it's a smaller chair. And if we place one in the world, or if we spawn one, it will have a radius that's about equal to the radius of those circles. Now we can spawn these chairs. So why don't we go ahead and do that for each of these points in the room, let's spawn a chair. So we can say, we'll come back up to our spawn item function. You'll see that we have this call to get world spawn actor. We can just copy that. And instead of item to spawn, which was a parameter for this function, we can simply use our chair for now. So let's find our chair class. It's called chair class, the T subclass of. We're going to use that. For the location, we're going to use random point in square. And for the rotation, we're going to use a rotator with a random yaw. So we can say float random yaw equals fmath finterp, not finterp, sorry, frand range from 0 to 360.f. And we're going to use this random yaw in a rotator here, f rotator, and it's going to be 0.f, random yaw, 0.f. That will give us a random rotation. So now that we're spawning a chair, let's take a look at how this looks. Now you'll see that everywhere there's a circle, there's a chair, and no two chairs are overlapping one another. So no matter how many times you run this algorithm, you will never see two chairs overlapping because they're always spawning, and they're never spawning at the grid lines. They're always spawning at least 25 units away. The center of the circle, and thus the center of the chair will always be at least 25 units away. So you'll see right here, this particular chair, it was almost at its limit. It would never actually go past the grid line. So now we have an algorithm that spawns a whole bunch of chairs, and it never ever will have any two chairs overlapping. We can do this as many times as we like, and they will never overlap. And it looks a little bit better when you comment out drawing the debug point, drawing the debug circle, and if we go up to begin play, we can comment out this call to create grid, and now all we're doing is spawning chairs on the grid. And now you'll see without the grid, without the circles and the points, it looks a lot more random, and you can't really, it's a little harder to tell that these objects are being placed in orderly little confined areas. Now, of course, the chairs will never go outside of their areas, so there's always going to be the same amount of chairs. In this case, a 5x5 grid gives us 25 chairs, right? There's always going to be 25 chairs, so that's not very random. And they're always going to be in their own little areas. And so, so that's one limitation of this procedural algorithm is that you're always going to have some level of predictability there, especially if you know the algorithm, if you know what it does, then you might not be satisfied with the amount of randomness. And so that is why in the next video we're going to start discovering exactly how we can randomize this a bit more without getting any overlaps, because we don't want any overlaps, right? We always want to have a random amount of items that are not overlapping one another. But we don't necessarily want an orderly grid every time. What if we want the grid sizes to be random, and we want a random number of grid squares? How do we accomplish that? So we'll get to that in the next video. We're going to get into some theory behind how to do that, how to partition the room into a bunch of different randomly sized squares and rectangles. So stay tuned, we'll do that in a future video. Until then, I hope you liked this video. If you did, feel free to thumbs up, like, subscribe, share, and sign up for notifications, all that good stuff, and follow Druid Mechanics on Instagram, Twitter, and Facebook. And thanks a lot. We'll see you next video.